Let's do a couple more examples of calculating left and right Riemann sums. Here we're given the graph of the function f of x equals cosine x on the interval from 0 to pi over 2. We need to calculate delta x and the grid points for the given function, and then calculate the left and right Riemann sums. To find delta x, we take the length of the interval and divide that by the number of subintervals, or another way to say that is the number of rectangles that we want. Here, n is equal to 4, and that gives us pi over 8. So our delta x, or the width of each of our rectangles, is pi over 8 units. So this means that our grid points will be spread out equally, pi over 8 units apart from each other on the interval from 0 to pi over 2. So that gives us the grid points 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. To find the left Riemann sum, we'll take our delta x and multiply it by the sum of the heights of the rectangles evaluated at the left endpoints. So the height of our first rectangle will be found by evaluating f of 0. The height of our second rectangle will be found by evaluating f of pi over 8. The height of our third rectangle will be found by evaluating f of pi over 4. And we'll evaluate f of 3 pi over 8 to get the height of our fourth rectangle. And we're going to round this value to 4 decimal places as needed. To find the exact value of this, we'll use Desmos. Desmos will give us a decimal, and we'll round that decimal to 4 decimal places. Pi over 8 times the sum f of 0 plus f of pi over 8 plus f of pi over 4 plus f of 3 pi over 8 is approximately 1.1835. And the next question is that an overestimate or an underestimate of the actual area underneath this curve? And as we can see, the left sum is an overestimate on this function because the function is decreasing on our interval. Using a left Riemann sum on a decreasing interval will always give us an overestimate because we're including area in our calculation that is not below the curve, as you can see here. Now let's do the same thing for our right sum. The right sum will be the delta x, or pi over 8, multiplied by the sum of the heights of the rectangles evaluated at the right endpoints. The height of the first rectangle is f of pi over 8. The height of the second rectangle is f of pi over 4. The height of the third rectangle is f of 3 pi over 8, and the height of the fourth rectangle is f of pi over 2. And it's interesting to note here that this fourth rectangle has an area of 0, because if we evaluate cosine x at pi over 2, that's 0. So the area of our fourth rectangle is 0. Again, using Desmos Scientific to do this calculation for us, we get our right sum to be approximately 0.7908. And now the question is this an underestimate or an overestimate? When our function is decreasing over our interval, a right sum will always produce an underestimate. And that's easy to see here because we've left out area that we should have counted here, 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 and here. All right, one more example. The velocity of an object is given by the following function on a specified interval. Approximate the displacement of the object on this interval by subdividing the interval into n subintervals. Use the left endpoint of each subinterval to compute the height of the rectangles. That's just another way of saying compute a left Riemann sum. And then we're going to round to 3 decimal places. So we're on the closed interval from 0 to 8, and we want to divide that interval into 4 rectangles. So how wide will each of our rectangles be? That's delta x. Delta x is the length of our interval, 8 minus 0, divided by the number of subintervals. So each of our rectangles will have a width of 2 units. Here's our interval of interest from 0 to 8, and I'm going to subdivide that into 4 equal subintervals, with each interval having a width of 2 units. Now let's find the displacement of the object. Remember, displacement given the velocity is just the area under the curve, and that's equal to delta x times the sum of the heights of the rectangles. Because we're going to use a left Riemann sum to calculate displacement, we'll start with the leftmost endpoint, 0. So our first height will be v of 0. The next rectangle will have a height of v of 2. The third will have a height of v of 4. And the last rectangle will have a height of v of 6. Now let's evaluate the function at 0, 2, 4, and 6. V of 0 is 1. V evaluated at 2 is 1/5. V evaluated at 4 is 1/9. And V of 6 is 1/13. Again, plug all this into our calculator and round to 3 decimal places to get 2.776 meters. So our displacement on the interval from 0 to 8 using a left sum for function v and 4 subintervals is 2.776 meters.